So here we have a question concerning the volume of a prism. And as I look at the shape here in front of me, I can see that I can easily break this down into two simple shapes. A trapezium, and when finding the area of the trapezium, I know the formula that is in the front of the exam paper, and on top I have a rectangular based prism. And in order to find the volume of a rectangular based prism, or better known as a cuboid, I just multiply its length by its width by its depth. Water leaks from the bottom of the trough at a constant rate. 2 hours later, the level of the water has fallen by 20 centimetres. So after 2 hours, the water level has dropped by 20 centimetres. We need to find out how much water that corresponds to. So in a 2-hour period, we've lost the entire volume of that top cuboid. And we said to find the volume, we'd need to multiply the length, which is 30, by the width, which is 20, by the depth, which is 120. Which gives us 72,000 centimetres cubed. The next thing that I'm interested in is that the water continues to leak from the trough at the same rate. How many more minutes will it take for the trough to empty completely? In order to work this out, I need to know how much water is left in the trough. And in order to do that, I need to find the volume of the trapezium-based prism underneath the cuboid. To start with, I'm going to find the area of the trapezium. So here's my trapezium, or perhaps it's better drawn the other way round. We know that its base is 80 centimetres. We know that its top is 120 centimetres, and we know that the width is 40 centimetres. In order to find the area of a trapezium, I need to half the sum of the parallel sides. So that's 1/2 of 80 plus 120. And I need to multiply by the height between them, which is 40. 80 plus 120 is 200. Half of 200 is 100. 100 times by 40 is 4,000. So I know that the area of the trapezium on the front is 4,000. As this is a prism, all I need to do now is to multiply by the depth of the shape, which is given to me here, and I know that the volume of water that's still left is going to be 30 multiplied by 4,000, which gives me 120,000 centimetres cubed. At this point, it's sensible to read again the bottom line of the question. How many more minutes will it take for the trough to empty completely? And really concentrate on the fact that it's asked us how many more minutes. We were told that it would take 2 hours for this water to leave. Now 2 hours is 2 lots of 60 minutes, which is 120 minutes. So we know that in 120 minutes, 72,000 cubic centimetres of water have leaked. Now looking at these two numbers, we should recognise that 12 will both go into 120 and into 72,000. So by dividing both numbers by 12, I find out that it would take 10 minutes for 6,000 cubic centimetres of water to leak out. Now I'm trying to find out how long it would take 120,000 cubic centimetres of water to leak. And I'm now almost there, because I know that if it takes 10 minutes for 6,000 cubic centimetres, it will take 20 minutes for 12,000 cubic centimetres, which means that it will take 200 minutes for 120,000 cubic centimetres of water to leak out. So our final answer is 200 minutes.